Welcome back, class 10th. Today we'll be continuing with exercise 3.7 of your NCERT textbook. Now this is an optional exercise and we have already covered all the questions except for question number 7th. Now question number 7th is just the basic question with a little twist. Now what do you have here is you have to solve these pairs of linear equations, but in the first 4 parts, what you observe is that the coefficients are not numbers. The coefficients are variables themselves. So for solving these, you require a little bit of patience and the knowledge of all the 3 algebraic methods. Now to solve these first 4 parts, you could use any of the 3 algebraic methods, preferably elimination or maybe cross multiplication. Now I am going to use elimination method in all of these parts and show you the solutions of the first 4 parts. The 5th part is a little different and we will get to it at the end. Let's start with the first one. Question number 7th, first part, we have px plus qy equals to p minus q. This is equation number 1. The next equation is qx minus py equals to p plus q. This is second equation and I am going to use elimination. Now if you remember, the elimination method means the coefficients of the term to be eliminated should be same. So right now if I want to eliminate the term with x, I can't do that, and if I want to eliminate the term with y, I cannot do that either. So I'll have to multiply the equations so that their coefficients become same, and then I will apply elimination. I'm going to eliminate the term with x. What I'll do is I'll multiply the first equation with q. So the first equation when multiplied with q becomes pqx plus q square y equals to q into p minus q. So px into q, qy into q, p minus q into q. Then second equation will be multiplied with p. So this multiplied with p becomes pqx, this multiplied with p becomes p square y, and on the right hand side p multiplied with p plus q. Now I can see the coefficients of x, they are equal, and since I want to cancel out these two, I am going to subtract the 2 new equations obtained. Let's subtract, it will change the signs, so the term with x is cancelled. Let's simplify. This gives you q square y plus p square y. On right hand side I've got q into p minus q, this term minus this term. Now it's all simplification. Taking y common, q square plus p square. On right hand side, let's simplify the brackets. pq minus q square minus p square minus pq. These get cancelled. So this is p square plus q square. Since it is addition, I can reorder the terms. From these 2 terms, let's take negative common. This binomial is being multiplied with y. This will be transposed to right hand side and it will be divided over here. Both the binomials get cancelled. I'm left with minus 1. So the value of y comes out to be minus 1. Now the equations were quite complicated if you look at them, but the answer is very simple. Let's use this value of y in either equation number 1 or in equation number 2 to obtain the value of x. I am putting this value in first equation. So put y equals to minus 1 in first equation. So the first equation is px plus q into y replaced by minus 1 equals to, on the right side, p minus q. So px minus q equals to p minus q. Px equals to, transposing minus q to right hand side, this gets cancelled. Px comes out to be equal to p. P is multiplied with x, transposed to the right hand side. P divided by p, x comes out to be 1. So this is the answer for the pair of linear equations given to us. Let's do the next part. Second part, we have ax plus by equals to c. This is the first equation. Second equation is bx plus ay equals to 1 plus c. Now this is kind of like the previous part. I cannot eliminate x, their coefficients don't match. I cannot eliminate y, their coefficients don't match. I'll have to multiply them with a number so that the coefficients match. Now I'm going to again eliminate the term with x. I'll multiply this with b and this with a. First equation multiplied with b gives me abx plus b square y equals to b into c. Second equation will be multiplied with a and it becomes abx plus a square y equals to a into 1 plus c on the right hand side. To eliminate these two, I'm going to subtract, changing the signs. The term with x cancels. From here, b square minus a square, y is common. On right hand side, bc minus a into 1 plus c. Simplify, this is bc minus a minus ac. On right hand side I've got b square minus a square multiplied with y. So b square minus a square into y equals to, these two terms contain a common factor c. So b minus a with c common minus a, y equals to b minus a into c minus a upon b square minus a square. This binomial was multiplied here, so you transpose it to right hand side, there it will be appearing in the denominator. So this is the value of y for this equation. Now you have to use this value to find out the value of x. Let's put this value of y in any of the two equations. I'll be using the first equation because that is a little simpler than the second one. Put y equals to the value obtained in equation number 1. So the first equation is ax plus by equals to c. Let's copy from here. Ax plus b into the value of y over this. On the right hand side I have c. Now it's all simplification. Let's simplify this bracket first and see what we get. So I have ax plus the numerator will be multiplied with b into in the denominator I have b square minus a square equals to c on the right hand side. Do it very patiently. I'm going to simplify the brackets first. So I've got ax plus b multiplied with b into b minus a into c. This will be transposed. In the denominator I have b square minus a square equals to c on right hand side. Let's take LCM here, or rather let's transpose this because I want the value for x. I don't need this to be here. This does not contain any variable. This will be treated as a constant. Let's take this constant term to the right hand side. Ax will be equal to c minus this complete expression bc, I've just reordered this product, minus ba over b square minus a square. Now this complete term over here is positive, so when you transpose it to the right hand side, only this sign will change, the first sign. This complete fraction, the numerator denominator as such, without changing the signs here. Let's take LCM. This is c over 1. The LCM will come out to be b square minus a square. Use the butterfly method. The LCM will be the product of these two, and for the numerator you cross multiply. Now let's use a bracket because it's a big expression. BC into b minus a minus BA. Now you have to simplify. Let's open the brackets. This becomes b square c minus a square c minus, inside the bracket I get b square c minus abc minus ab or ba, and the denominator b square minus a square equals to, opening the brackets, this is b square c minus a square c minus b square c plus abc plus ab, in the denominator b square minus a square. These terms get cancelled, and overall from these three, a is common, so I'm doing that side by side. These two terms get cancelled. The remaining three terms have a common. I'm taking that a common and I'm reordering, writing positive terms first, the negative at the end. So I've got bc plus b minus ac. In the denominator I have b square minus a square. Simplifying this further, on the right hand side we have simplified value. Let's bring the left hand side over here. This and this a, they get cancelled, so x comes out to be, combining these two, c is common, so b minus a in the brackets, outside I have c plus b, in the denominator b square minus a square. So these are the values of x and y which are making the answer for this pair. Let's do the next part. Third part of the same question. I have x over a minus y over b equals to 0. This is equation number 1. And the second equation is ax plus by equals to a square plus b square. These are the two equations given to me. Now what I'll start with is, I'm going to simplify my first equation. I've got fractions here and I don't want to work with fractions, so I'll be simplifying my first equation by taking LCM on left hand side. So let us see what we have. Again, I'm using the butterfly method for taking the LCM. LCM will be the product of the denominators AB. For the numerators, cross multiply. bx minus ay equals to 0. Transpose this AB to right hand side. It will be multiplied with a0. This becomes 0 on the right hand side. So this is the first equation simplified. You could use a new number, I'm just referring this to as 1. Now I'm going to solve these two. Again, I want to use elimination, observing the coefficients do not match. Over here the coefficient of x is b, and in this case it's a. So this will be multiplied with b, this equation will be multiplied with b, and this will be multiplied with a. So let us see what I get. Multiplying first equation with a, this equation with a, this gives me abx minus a square, while the right hand side is 0. 0 multiplied with any number is 0. Second equation will be multiplied with b, so that gives me abx plus b square y equals to b multiplied with a square plus b square. To eliminate this term, I'm going to subtract. Change the signs. The term with x gets cancelled. So I'm left with minus a square y minus b square y on the left hand side. On right hand side, I've got 0 minus b into a square plus b square. Let's simplify. Taking y common or minus y common, I will be left with a square plus b square in the brackets. Right hand side is minus b into a square plus b square. Negative from both sides get cancelled. This binomial is multiplied with b. Let's transpose it to right hand side. It will appear in the denominator. Now these two binomials match, they'll get cancelled. Y comes out to be b. Now use this value in any of the two equations. I'm using it in equation number 1. You can see this equation and this equation. This one is simpler. So I'm going to use the value of y which I obtained over here and find out x from this equation. Put y equals to b, the value I just obtained here, in equation number 1. Equation number 1 is bx minus ay equals to 0. So bx minus y will be replaced by b. Bx minus ab equals to 0. Bx, transposing this, 0 plus ab. Bx will be equal to ab. B is multiplied with our variable. On right hand side, it will appear in the denominator. B and b cancelled. X comes out to be a. So the answer for the given pair is x equals to a, y equals to b. Let's do the fourth part. Fourth part, I've got a minus b times x plus a plus b times y equals to a square minus 2ab minus b square. This is equation number 1. Equation number 2 is a plus b into x plus y equals to a square plus b square. This is equation number 2. Now equation number 1 is okay. I've got a term with x, a term with y and a constant term. But in equation number 2, I have a problem because I have the terms with x and y put together here. So I'm going to use distributive property. Treat this as the number outside the bracket. So if this is the number outside the bracket, this will be multiplied with x and the same number will be multiplied with y. I'll get the equation as a plus b into x plus a plus b into y. And the right hand side is a square plus b square. Now this is the simplified form of equation number 2. I'm using the same number here as well. Now I want to use elimination here. Now I don't need to multiply in this particular part because the coefficients of y are matching. This is a plus b with plus sign. Over here also a plus b with plus sign. I simply need to subtract these two and the term with y will get cancelled. So let's subtract equation number 1 minus equation number 2. So what I've got is a minus b times x plus a plus b into y. Right hand side is a square minus 2ab minus b square. Let's write this equation, the one to be subtracted below here. A plus b into x, the second equation, plus a plus b into y equals to a square plus b square. Since I'm subtracting, the signs will be changed. Negative, negative. This is positive, this becomes negative, this also becomes negative. The term with y will get cancelled. Let's note down the terms left. This term minus a plus b times x equals to a square minus 2ab minus b square minus a square minus b square. Now we have to simplify. Let's take x common from here. in the brackets a minus b minus opening the brackets simultaneously equals to a square and a square cancelled minus 2ab minus 2b square. Over here a gets cancelled, x multiplied with minus 2b. Over here I can take minus 2b common, I'll be left with a plus b. So x equals to this product will be transposed to right hand side and it will appear in the denominator. These two terms get cancelled. X comes out to be a plus b. Now what I have to do is I have to use this value of x in any of the two equations and find out the value of y. Let's use the value of x in equation number 1. X equals to a plus b in first equation. So the first equation that we have is this. Put x equals to a plus b in equation number 1. So a minus b into a plus b plus a plus b into y equals to a square minus 2ab minus b square. Take your time. This is an identity. So this will be a square minus b square plus a plus b into y. This will be right hand side as such. Let's take this constant term to right hand side because this does not contain any variable. A plus b times y equals to a square minus 2ab minus b square minus a square, signs changed, plus b square. So this term gets cancelled, this term gets cancelled. I'm left with a plus b into y equals to minus 2ab. Now a plus b is multiplied with y. On right hand side it will appear in the denominator as a binomial. So this is the value of y and x came out to be a plus b. This is the answer for the given pair.